All right, let's do a problem involving forces of friction and coefficient of friction and some free body diagrams here. So we're going to do number 2. And it says a force of 300 newtons is sufficient to keep a 100 kilogram wooden crate moving at a constant velocity across a wooden floor. What's the coefficient of friction? So let's just start with our diagram up here. We got a box. Don't pay any attention to my sloping floor there. Sitting on the floor, and we've got an applied force of 300 newtons, and we know that it's going at a constant velocity. So there's a couple of things that's been told to us, and then we can imply the rest. So if this thing is a 100 kilogram box, and I'm letting you use 10 meters per second squared as gravity, I can calculate that the force of weight is equal to mass times gravity. That's going to be 100 kilograms times 10 meters per second squared, that's 1,000 newtons. And because it's at a constant velocity, we don't have any net forces on this thing. So the normal force is also going to be 1,000 newtons. Kind of squeeze that in there. And that means that the force of friction is 300 newtons. So there's our box. It's all in equilibrium, moving at a constant velocity. And the question was, what's my coefficient of friction? On this point, you have to go back and you have to remember that the force of friction is equal to mu times the normal force. With a little algebra magic, we'll just say that the force of friction divided by the normal force. And then we'll just go ahead and divide it. 300 newtons divided by 1,000 newtons. In one of the rare cases in physics where there are no units, the newtons cancel. 300 divided by 1,000 is 0.3. And you can bask in the glorious joy of knowing you don't have any units to deal with for one problem. So the coefficient of friction is 0.3.